Okay, so you know very well the steps to perform convolution, right? So you will be having input and kernel, and then different levels of convolution you will do. For that we need different steps like sliding, padding, right or not. So here how we are representing that each and every step using in linearly. That is the concept here. So initially we have kernel input, right? Input I. Okay. Then kernel. This representations are nothing but I already told you. If you are taking a colored image, it will be having three different channels, right? What are the channels? Red. Using the basic primary colors, the channels will be there, right? So red, blue, green. Likewise, we have channels, right? So this is a unit in channel I of output. So remember, the thing is, one neuron will be connected with another neuron in the next layer, right? So one's output will be given as input to another neuron. Am I right or not? In order to perform computation. So here I is taken as suppose a unit in channel I of output, and the next is a unit in another channel J, which will take the output of previous layer I, and that will be input for channel J. Okay, so input. Then K number of rows and L number of columns. So which is nothing but we are representing in a linear form. In the problem, you are having 5 into 5 input image and 3 into 3 kernel, right? So this 3 into 3 kernel, this is what we are representing in linear form. Okay, K, I, J, K, L. So V is nothing but V, I, J, V, J, K is nothing but a value in a particular, an observed value. So you will be having, this is a 3 cross 3 matrix and this is a 5 cross 5 matrix. In that matrix, you are having some value, right? A value, observed value. Suppose 10, 5, 10, 15. Likewise, you will be having value, right? That will be represented as B. Okay. So in channel I, jth row, kth column. Okay. This is or channel, G channel, P channel. Suppose for everything you will be having some matrix, right? Do you remember we have seen on tool? CNN Explorer. So for when you are clicking each and every image, in between convolution image also you can able to see the matrix values. Am I right or not? So each and every channel you will be having values. For example, this is channel I, and in jth row and kth column, the particular value, the value inside that particular place, we are representing as this as B, capital B, kernel A, capital B. The output produced using the input and the kernel. So by taking the product and summing all the products, you will be getting result, right? So all the summation. That's why here we have summation of. Okay. Here you will be doing value and the product of, in between nothing is given, plus not given. Nothing is given means it is a product. If A, B, what is the meaning? A equal to 4, B equal to 3. What should we do?
4 into
4 into 3. The meaning is product, right? So here value into kernel value. The product should be taken. This is initial one. Okay, so when you are sliding over, in order to reduce the dimension, we are sliding over. So that's why the extra terminology S will be taken. So this M and N, or if you are moving, what is the total number of rows and total number of columns in a particular matrix? That represents the M and the N. S represents number of steps you are sliding. that will be represented as S. So before at first step, linear representation of the product is this one, and after sliding, the linear representation of the product is this one. Got it? Same thing we are doing. Just we are going to multiply the input matrix and the kernel. We are representing using this structure in theoretical part. Okay? In problem you have to do like this only. You will be having values. You have to take first value in the input matrix and first value in the kernel. You have to take product like this. Sum all the values. You will be getting a resultant value. That is our first value in the intermediate matrix. Then you will be calculating sliding. After sliding, you will be calculating this value. Then third, fourth, likewise, we will be obtaining the resultant one. Got it? So either this is what CNN. Okay. Suppose no convolution in certain cases, in certain applications, there is no need for convolutions. So at the time we will be using the traditional method only. So that we are calling this as locally connected layer. Okay. So the locally connected layer in the sense the same. The traditional one, the previous class we have seen, right? Each neuron will be connected with all the other neurons in the next layer. Whether the same procedure applicable in the CNN? I am asking you only. Whether every neuron in the input unit will be connected with all the neurons in the next layer in CNN? No. We are reducing, right? That is why we are going for CNN, right? Suppose if convolution is not needed in certain cases, we can able to go with the traditional method. We are calling this as locally connected layer, right? Here, each and every connection has its own weights. Every neuron will be connected with other neurons and it will be has its own weight. Then here we are representing this as linearly. So I is the output channel. We are representing L, small l as input channel. And in output channel, J is for output row and K is for output column. And in input channel, M is for input and N is for, input row and N is for input column. So how we are representing this as? Instead of kernel, whether kernel will be applicable here, only for convolution we need kernel. If convolution is not needed, that's why we are going for traditional approach, right? So here each one is having its associated weight, the product of the value with its weights, right? With its weight, the summation, the whole summation will be done in order to get the output. So this is also called as unshared convolution. So normal basic property of convolution is parameter sharing, then sparse interaction between the neurons, equivariant. Likewise, we have seen three main properties in convolution, right? So we are not using convolution here. We don't need the alternative approach is local connection. We are calling the layers as locally connected layer. The another name is unshared. We are not sharing the parameters here. We are not sharing anything here. So every input will be multiplied with the associated weights and the whole summation will be our output. That's it. Right? So that's why this is also called as unshared convolution. Got it? Same procedure. Again, I am telling you the procedure is same. You have input and then kernel. We are just doing the stride only. Stride means you know very well. You will be taking N into N matrix and M into M kernel. You will be multiplying is the concept is same, but how we are, this is what the just representation of the matrix without striding and with the striding. Got it? Clear? These are simple concepts in convolution: structured outputs, data types, and algorithms, efficient algorithms used in convolution. These are the inbuilt concept which is associated with the convolution neural network. So structured outputs, in the sense, the convolution neural network will provide high dimensional and structured output when we compare with other neural networks. So here the output size will be probably equal to the input size, not about the pixels. Spatially, we can able to accommodate input size. That much size will be accommodated in the output also, but we are reducing. That is a Manoj. That is the concept of CNN. We are reducing. Resultant matrix, we are taking the input as 5 and 5 cross 5 matrix. The resultant is 2 cross 2 matrix after factoring. That is different, right? So spatially we can able to accommodate. The output size will be equal to input size spatially. The meaning is that much size will be accommodated, can be accommodated. There is no mandatory that the input size should be equal to output size. Okay, we can able to accommodate that much size. Input size is equal to output size spatially in convolution neural network. Then how we are representing this as S of ijk, which means that this is our row and this k is our column. The meaning is this particular value is probably available in jth row, in kth column, and also in the ith channel. That is the meaning of this representation, S of ijk. Okay. So another property is, suppose we need the property I have told you, right? The input size is equal to output size. So we need the output map with the same size, means same size as in the input. Means we should definitely use same padding. We have seen 3 different padding, right? Valid, same, and full padding. So you are using full padding means probably you will be reducing the dimension. That is this alternate case. Suppose you are using same padding means wherever needed, wherever the value is not available at the particular corresponding pixel only, you are going to pad means that is same padding. If you want to have the output map with the same size of the input one means we have to use same padding strategy. So another cases, if you want to reduce it means the alternate case, that is shrink. We are reducing the reduced map. We are calling that map as force segmentation map. So simple example is given here. How we are creating force segmentation map. So here the base concept is parameter sharing. Based on the sharing concept only we can able to reduce the dimension. We should not forget. That is the core property. So without sharing we cannot able to reduce, right? We cannot able to shrink. Isn't it? So based on the shared property, shared parameters only we can able to shrink the map, output map from the input, right? So this model is also will be calling it as recursive model. Recursive models, why it is recursive models in the sense some parameters are shared, right, which will be used for here. For example, h1, h2, h3 are taken. These are shared parameters, h1, h2 and h3. We have input x and in order to provide output y, y1, y2 and y3. So So using the shared parameters, we are producing the output y from the input. Here, this value, we are taking this value, right? So we will be producing some output, that is w, which will be taken as input to the next one. So which has some properties of w. Am I right or not? So here this one, this parameter has some properties of the previous one. Am I right or not? So sharing the parameter, using the shared parameters, we are creating the output from input so that we can able to reduce the dimension. So the main concept is parameter sharing in order to shrink the output. Easier ஞாபகம் remember this. First, this is taken right. It's line 2. Which one should be taken? This one should be taken. Am I right or not? So what about the middle one? Which will be either available in this part or this part. So shared one. That's why we are reducing this, right? Based on the sharing parameter concept only, we can able to reduce the computation, right? That is the main concept. So neural network, convolution neural network provide structured outputs when compared to other neural networks. Got it? So next topic is data types.